Good evening, ladies and gentlemen. I am Prashant Silla, Secretary of Electrical, Electronics and Telecommunication Engineering Sectional Committee. And let me give a little brief on this today's evening event. This is the first public lecture organized by our sectional committee in this session. Today's lecture is very important to all of us because this has become a part of our life. We can't think about a moment without this because it is so close to us. But are we in the safe side comparing present status and future planning? The topic today is present status and future of Sri Lankan power system. On this subject, we would like to know present demand and supply, available avenues to improve the generation, and challenges to be faced while planning. Not only that, we will make aware on our strengths, weaknesses, opportunities and threats in this field as a country. To discuss this, today we have eminent characters with us who can enlighten us on the subject thoroughly. Let me introduce our resource persons. Engineer Dr. H.M. Wijekoon Banda. He has passed out from University of Peradeniya in 1993. Has completed his Master in Engineering in 1998 from AIT Thailand. And also he has completed his PhD in 2005 from Singapore Nanyang Technological University. Engineer Wijekoon Banda has 25 years of experience on electricity transmission and network planning, stability and power quality studies. He is performing duties as the Chief Engineer Transmission Planning, Ceylon Electricity Board. Our second presenter, Engineer M.B.S Samarasekara. He has passed out from University of Moratuwa in 1996. He has 21 years of experience in generation planning and designing renewable energy integration studies, transmission maintenance and transmission design functions. Presently, he is performing duties as the Chief Engineer, Generation Planning, Ceylon Electricity Board. It is no doubt that these two presenters are the most suitable personnel to discuss a topic in this nature. Without further ado, let me invite both Engineer Dr. H.M. Wijekoon Banda and Engineer M.B.S Samarasekara to conduct their presentation. Over to you, sir.
Good evening to everybody. So today we are going to present basically the generation plan, which is a 20-year planning horizon, and also I mean mainly my colleague Buddhika will carry out the presentation. For the completeness of the presentation, I will just briefly give you some highlights of our transmission network. That means the whole presentation will be focused on the power system, the generation planning part. Actually, we are basically doing this exercise for many years, and also for last 3 years, what is happening is actually due to various reasons we are struggling to get the approval. But the other part is actually without getting the approval for the generation plan, so you can't prepare the transmission plan. So therefore you can imagine where we are now. So especially preparing a transmission plan without the input of a generation plan, and then I mean carrying out transmission strengthening, which are getting very lengthy period of time, it will be a very, very difficult task. So therefore, the timely getting approval of these two plans are very vital in order to provide the reliable and quality power supply to the nation. So therefore, we are making presentation what is the outcome of our plans, the planning methodologies, in a various form, just to make aware of what we are doing. So taking much time, so I will hand over this to my colleague Buddhika. He will carry out the presentation on generation plan, and then after that I will just highlight the transmission network, which is basically generation plan what is going to present now. Thank you.
Okay, good evening. I am Wijekoon, Samarasekara, Chief Engineer, Generation Planning. I will go through my outline of my presentation is as follows. Okay, I will do some present status and what would be our future forecast, what are the proposed capacity additions, what are the commitments to the COP21 and environmental aspects, what are the environmental mitigation activities we have taken with the externalities in our generation plan, impact of specific costs with fuel prices, comparison of energy mixes of other countries, and also what are the major generation projects in the pipeline, because that would be up to 2030 I would do. Then Dr. Wijekoon will do the present transmission network developments for next 10 years. Then what are the future transmission investment commitments up to now, what we have done and what we need. Also now the discussions are going on about the HVDC link between the India and Sri Lanka, and the financial impacts of delays, and also what are the immediate actions and the conclusions. I think within 1 hour we will do our presentation. Maybe I will trust some slides. Whatever the questions, maybe we will answer after the session. This is the capacity mix and energy mix for the 2017. Actually, there will be slight reviews on these things because there are some mini hydros, renewable energy power plants. We have to get the information later, but almost in 2017, our energy, this is the total energy, okay, not the demand, 14,620. That means 14,620 gigawatt hours we have generated using CB hydro, CB coal, CB thermal, IPP thermal and other renewable energy. And this is the energy share for the 2017. You can see coal has done the major significant part, 35%, and CB thermal and the IPP thermal equally shares. That means 34%. Those are mainly diesel and other fuel, that means naphtha, HFO, and CB hydro around 21%. Other renewable energy only 10% contribution share from in 2017. That is mainly, you can see mini hydro contribution is very low, 2017. Here you can see normally we plan around 4,200 gigawatt hours energy from our major hydros. It's around 1,000 gigawatt hours reduction in 2017, mainly due to the drought, severe drought. That's why this thermal contribution is more. And this is the renewable energy status. You can see this is, I am talking about the total renewable energy. This blue line represents the major hydros, and all the other renewable energies, that means wind, solar, mini hydros, dendro, that we categorize under other renewable energy. You can see there are some years we have got around more than 60% energy from the renewables. That means our country still we have a potential, but main issue is we are dependent on the hydro. That means 2013 was a very wet year. Because of that, our major hydro has contributed more than 6,000 gigawatt hours. On average, we are having more than nearly 4,000 gigawatt hours, but 2017 was a worst year. Okay, there were some worst years, but 2017 is not a good year. You can see the variation of the percentage. It can vary because it's still we have maintained more than 30%, and it could vary more than 60% energy from the renewable energy with the present system itself. And these are the present status of the other renewable energy projects. Those are already commissioned projects. There are so many projects under, we have signed SPPAs and LOIs, but those are commissioned projects. These commissioned projects comprise of mini hydros around 354, biomass and dendro around 26, solar power parks. These are 5 parks, 10 megawatt park and 1 small scale park belong to the Sustainable Energy Authority. That's comprised 51 megawatt. And wind power 128 megawatt. Now total we have up to December 31st, we have commissioned around 560 megawatt, and in addition we have commissioned nearly 120 megawatts of rooftop solar up to now, because there was a huge program under Surya Bala Sangramya. Previously, I think this year was started around 2017 was started around 30 megawatt of rooftop, but now we have achieved more than that under commissioning. That means this will be around 150 megawatt within before March. There are so many projects going on. I think that project is going smoothly, and we are encouraging that rooftop program to reach, because there was a target 200 megawatt by 2020. I think we can easily achieve that target. This actual average unit cost for electricity. You can see the 2016 and 2017 CB hydros. It's only a overheads, administrative cost. Coal 2016 around 658, 9 rupees in 2017. You can see thermal cost has been increased, and these are the average cost at selling point. In 2015 is 15 rupees, in 2016 18 rupees, and 2017 21 rupees. Mainly why you can see a clear increase, mainly due to the drought. That means we have to run more and more diesel thermal plants to cater during the 2017, and you can see our average selling price in 2017. These values may slightly change depend on the final corrections, but maybe this could be a very good indicative prices. 1754, and actually in 2017 itself CB had a loss for 39 billion. You can say every unit we are having a 4 rupee loss. It's a huge loss to the country. This is ultimately borne by the consumers, because we have to think, because that's the indirect way of non-implementation of major power plants. That's the major issue. Okay, drought, that's a part contribution, but there were mainly we have to run our thermal plants. And you can see the energy cost actual. Here you can see, just I am trying to give you one significant component. Here CB hydro unit cost is like that, thermal, coal, IPP thermal, renewable energy, and this is the levelized generation cost for 2017, and this is the average unit cost. That means this component mainly due to transmission and distribution component. That means there are transmission and distribution losses, there are so many investment in the distribution side, transmission, that, and CB administrative cost, all the things. That means it's like a fixed cost. That means at least around 6 to 7 rupee fixed cost we have to bear from generation levelized tariff to selling point. Because everyone is thinking, if we introduce a power plant below, let's say for this particular case, if we introduce a power plant below 21 Sri Lankan rupees, that would bring down our energy cost. That's not the case. Because for this particular year, if you want to think, you have to have a power plant at least below 1441. That's the must. Otherwise, indirectly you are increasing the average unit cost. Because when you look at this comparison, only hydro and coal are below our generation cost. Okay, because this renewable energy is having a mix, because there are power plants, mini hydro is having that, wind, some, because there are different tariff categories. You have to think, because this is a total cost I am talking about, because when you look at the mini hydros, okay, those are below this 1441. Okay, that we have to accept, but there are solar plant at 2310, there are wind power plant at higher than that, it's in the 3-tier tariff. But whatever the power plant, if we want to introduce into the system, we have to think about this kind of range. That's the main thing I want to emphasize. And this is the forecast we are talking about for the next 20 years. Okay, actually this our generation plan is a revolving plan. Every 2 years we are updating. Now at present we are having around 15,000 gigawatt hours. It's 14,620, because there are so many governments, new industrial, so on, so many commitments, and also there are so many new developments, and our GDP also increasing. Based on that, our projections, we think around 5% electricity growth for next 20 years, and that will reach around 40,000 gigawatt hours around 2040. But this is because actually to prepare the generation plan, we have to have a demand forecast. Our main restriction is only CEB is doing for the 25-year plan. All the other stakeholders, let's say if we go for the central bank itself, they are giving only 4-year GDP projection. And that 4-year GDP projection also they are not giving for the different categories. Because we want to categorize industries, commercial sector, domestic, religious, all the other transport sector, but for that particular 2017, let's say 2017, they are having the actuals, but for the projections, they also don't have the direction for the sectors. But we have to assume so many things. And this, okay, and also we are every time getting the information from our distribution planners and all the other major government stakeholders, let's say megapolis and other major developers, and we are focusing to develop this forecast. And based on that, because I am doing just a summary, this is the generation plan we have submitted to the Public Utility Commission. This having for next 20 years thermal around 4,600. Out of that we propose coal 2,700, LNG 1,500, gas turbines, reciprocating engines, because we need different types of machines to cater the different aspects of the power system, because we can't run a power system having only one type of power plant. Because as a system operator, you have to look into the different aspects, maybe peaking, maybe load following, maybe frequency controlling, different types of power plants. And we are proposing new major hydro additions around 240 megawatt. Our main component is the renewable energy. We are proposing 2,800 megawatt of renewable additions, mainly wind, solar and mini hydro, mainly the wind and solar. You can see the breakdown, and also we are proposing a 600 megawatt, actually 3 into 200 megawatt pump storage power plant also in our system. Yes, our integration of renewable energy is around 37 megawatt per year, but next 20 years we are proposing 145 megawatt on average per year. That means country has to invest around 22 billion Sri Lankan rupees per year only for the renewable energy sector. I am not talking about the transmission sector. It's a huge value. It's not a small value. It's around 150 million US dollars investment country has to look into. Because mainly these renewable energy developments, we are requesting private sector to develop. That means we are talking about next 20 years is ORE plants. Our cumulative capacity is around 3,500 megawatt in our system. Because this is because there are so many things. Some says okay, we can go for 100% renewable energy system, because from planning as a planners we have to do a proper system analysis. That means system analysis means we have to look into the system stability side, operational aspects, cost side, and mainly the dispatching. Whether we can dispatch these power plants in an optimal manner. Then, okay, there are balance, compromise. Based on that, we are integrating the renewables into the system. And these are the environmental aspect. At present, this is the IEA 2016 edition. This is our Sri Lankan present status. Our present status is we are emitting around 16.7 million tons per annum of carbon dioxide. You can see our neighboring countries and other countries and the world average. This is the real values. This is the per capita. Normally, you can compare these values. Our per capita is around 0.81. World average is 4.47. When you look at the breakdown, this is the structure. That means transport sector is the major contributor, and electricity sector or the transport sector is around 48%. Power sector is around 41%. And when we put up our plan, because this is a commitment, we have to show, and this is the present value, and we have given several scenarios in our generation plan. Based on these scenarios, we have projected the total CO2 emissions in that particular year. That means you can see still, let's say if we go with our base case also, this is only the power sector I am talking about. Power sector will increase like that. And what are the externalities we have considered? There are two types of externalities. One is the local externalities, other one is the global externalities. Normally local externalities, we have to look into the locational aspects. That's the main thing, because this actually, let's say if CB wants to build up a power plant or the IPP developer wants to develop a power plant, first they have to go through the environmental impact assessment process. That EIA process, it's beyond CEB. That means we can only submit our basic information questionnaire, and Central Environmental Authority, they will form a committee and they will give a terms of reference. Based on that terms of reference, power plant developer, maybe power plant, whether we develop wind or solar or whatever the power plant, we have to follow that procedure. Based on that terms of reference, we have to prepare the EIA assessment, and that will and we have to get the confirmation of actually approval from the Central Environmental Authority before implementing that particular power plant. And in that EIA report, they will give plant-wise mitigation proposals. That means first developer has to propose, these are the commitments we are proposing. Maybe they will satisfy or they may not satisfy. Based on that, we have to update our EIA process. Global externalities means what could be the global emissions. Global emissions means we have to look at our overall plan. That's why two options we are looking at. One is to increase the renewable energy component, and other one is to increase the efficiency of the power plants we are proposing. Those are the two mitigatory options we are going ahead, and based on that, I think our Sri Lankan government, they have signed for the COP21 commitment, and according to the COP21, Sri Lanka expect to reduce 20% GHG emission in energy sector. Actually, this is purely energy sector, but we think this is electricity sector. 2070 against business as usual scenario as unconditionally 4% and conditionally 16%. That we have to bound. And when we are preparing our long-term generation plan, we have to define what would be our committed project. what would be our uncommitted? That means unconditional. Conditional means those are we have committed. That means we have to ensure that one. That's a must. Sri Lanka has to, as a country, we have to ensure that one. Other projects, okay, if the government having sufficient money, government can do, or otherwise government can request external agencies to support. Because you can see, according to our this generation plan, we have selected these as committed plants, because now we have float a tender for the 2 into 10 megawatt wind park, and I think today we awarded 1 megawatt 37 projects. That also we considered as a committed project, and another 2 into 10 megawatt solar we are, I think, already under tender. In 2019 itself, we think we can integrate around 70 megawatt of rooftop. I think that will be more. Kumawaya will be in 2019, Broadland will be in 2020, and Mana wind project, I think we can commission by 2020 and 2022 Moragolla. But here we have maintained the national commitment as 4%, and our conditional commitment 19% in our plan, because government has signed for the 16%. But only thing is, maybe in next plan there are some projects will move as a committed project, and also there are so many new things. We are going with the NDC, there are energy policy, we are going with some CDM mechanism, we are developing a fuel quality roadmap, loss reduction programs, and main thing is the demand side management and energy conservation. Based on our previous generation plan, government has set up a separate unit called Presidential Task Force for Demand Side Management under Sustainable Energy Authority, because actually we didn't take those things into here, because those are, we consider it as a bonus. But definitely, because one option is, if we can reduce the demand, automatically we can reduce the energy generation. And these are the impact on the specific cost. Here actually there was some confusion between our plan and the PUCSL plan. CEB we use the 2-year average fuel prices, PUCSL use the 1-year average. We use 2015 and 2016 average, PUCSL use the 2016 average, and also they compare the quarter 2016 fourth quarter average. Whatever the cost, you can see as a energy cost, this is the impact. That means, let's say 300 megawatt combined cycle LNG, if we go for 2-year prices, price is around 9.37 US. I want to emphasize why we look into this particular prices. What kind of price we have to look, because in internationally acceptable way of doing the planning is you have to go for some fixed prices, because this is, we are talking about the 20-year plan. That means 20-year plan we can't use actually a escalated price. Normally for the preparation of the base case plan we use a constant dollar value, and we do some sensitivities to check what's the robustness of the plan. And actually we are deriving based on the international, not by our own self, we use the international acceptable projections, mainly the IMF, World Bank. You can see these values. This is the LNG constant dollar term, this is the 2-year average value, this is the 1-year average value. And if you can see, if we use the 1-year average, 2016 was a LNG price was very low. And coal prices, here we use 2-year like this, 1-year price is like that. This is actually without, this is CIF price we are talking about. And what would be the reason fuel prices? Because you should look into the future also, because this is, we can't do a plan by looking at the one particular price itself. We have to look into the what kind of trend in the fuel prices. This is the global coal prices. Okay, we can see that Australian coal it's going up in the market. Same way, LNG also somewhat reduced, but again going up. Now when you look at the LNG prices, it's around $10 per MMBtu. Coal is around $80. That's the way. Because of that, every time when you are looking at the plan, you have to think, and your plan should be robust. That's the main aspect we have to consider when we are doing a long-term generation plan, because we can't depend on one fuel only. Actually, this is the base case plan we propose in our long-term generation plan. You can see we propose coal 47%, LNG 17%, renewable and pump storage is around more than 35%. But we had some discussions with the government. There are so many discussions because we submit this plan in 2017 April. Then there were so many discussions. Then there were some compromises. Then there are some government requests. All the things we consider, and we, from CB point of view, we came to some compromise. That compromise is we increased the LNG component because there were government to government commitments from government side, and you can see from CB side we increased the LNG commitment, but there is a cost associated on that, but that's we consider it as a government policy cost. Okay, and this is coal 41%, but renewable share whatever the plan is set. But still this is under discussion. This is not the still not the approved plan, because this is the status, present status of the plan. And just see the energy mixes, because these are we obtained from the International Energy Agency World Energy Outlook 2016, but don't think all these are rigid solid values. These are changing. Okay, here you can see our energy mix around 42 coal, LNG 23, renewable we are maintaining more than 35%. And you can see USA in 2040 coal 25%, LNG here, China, these countries, and renewable share. I think renewable share out of this is European Union. This is not a one country. You are talking about the European Union. You can see the renewable share, because our country still maintain more than 35%, because this is one snapshot. Because anyway now everyone is telling solar cost is going down, all the things. Our next generation plan, this is a revolving plan. We may increase the energy component. These are some of the countries I have extracted, because our shares are more than, our renewable share is more than all the other countries. And what are the major renewable projects? Because actually based on this generation plan, we have to initiate our projects. And there are some projects we have initiated previously, but there are new projects we are initiating from this new generation plan. So Umaoya is under construction, Broadland is under construction, Morogolla I think already detailed design completed and maybe tender will be float. There is a irrigation, Ministry of Irrigation, they are carrying out a big project called Talpitigala in Lower Umaoya. Ginganga Irrigation, Ministry of Irrigation is doing. CB wants to do the pump storage. We have carried out the pre-feasibility study. Then the Manawin Park, now we have already evaluation stage. Now it's okay, it's tender, not the tender process, now it's under evaluation. Now after finalizing this 1 into 37 megawatt, because actually we previously called for 1 into 60 megawatt, out of 60 megawatt which 37 were qualified. Then our ministry wants to increase the 1 megawatt share. That means now I think already we have prepared the tender documents, and that will flow, that will publish maybe within next 2 weeks time. Another 1 megawatt into 90 locations. Actually, we have given 30 grid substations, each grid having 3 megawatt each. Because it's a very successful bid. The price was drastically down because we set a ceiling price for 1837 for the solar, and price was vary from maybe around, I think, 1186 to 1837. But that's under competitive bidding procedure. And these are the solar power developments in the near future. We are going with the rooftop solar power program. Okay, government has given us the target 200 megawatt by 2020. Now we have already achieved around 120 megawatt, and our next year plan is around 70 megawatt. That means automatically we can achieve that one. Okay, maybe if we achieve more, that would be a bonus to the Sri Lankan power system. And 19 to 1 megawatt solar, then 10 megawatt solar park, and main important thing is we are going ahead with the utility scale solar parks. That means 2 solar parks. Now we are almost, we got the World Bank support to carry out the feasibility studies, and today morning also we had a very fruitful discussions. Now they will carry out as a park. Punareen, initially 100 megawatt solar park. Siamalanduwa, Monaragal area, initially 100 megawatt solar park. Okay, maybe that will be split. That means that the area depend on the land availability. That may be split into 25 into 4 or 20 megawatt into 5 or like that. But in that particular area, we are going ahead with 100 megawatt solar park and associated transmission network also we have to invest. And also government wants to look into some floating solar also. Now we thought, okay, initially, okay, when we are getting the proposals, we are getting 100 megawatt scale, 500 megawatt of scale proposals for floating solar also, because we thought with the SCA and the ministry, first we should go for some pilot scale project. Because, okay, we can say yes, but we have to see the other stakeholders' views also, because they are talking about Chandrika, they are talking about Parakram Samudra, they are talking about Maduroya, all the reservoirs. But we have to see the impact of the fisheries and that aspects, we have to look into that. But we will open the park solar as well. And the wind, now I think our project director also here, Mana Wind Power Plant, phase 1 under ADB funds, we have opened the tenders. Now I think we have evaluated, and almost now that will award. And we think by 2020 that will be commissioned in our system. And Mana Wind Park phase 2 and 3, because we thought Mana would be developed by the CEB. That potential is around 375 megawatt. Okay, maybe there are some social and environmental aspects in that area. Maybe we can develop around 250-300 megawatt. That will be a phase development. Before going ahead the second phase and third phase, we thought to open another area, that's the Punareen. Punareen, now a Sustainable Energy Authority, they have indicated that initially we can develop around 170 megawatt of wind, 170 megawatt wind and 100 megawatt of solar system as a first stage. There are so many environmental concerns, there are sand dunes, there are other aspects, we have to respect all the things. And based on the but definitely I think we can develop that initial stage. There are good potential, but the main issue is whether we can develop that total potential or not. That we have to look into, that we have to look into the environmental aspects also. But anyway, we are going with that. And the major thermal power plants in the line, because due to the cancellation of the Sampur power plant, we have to go for some short-term remedial measures. Because of that, we need some power plant to cater the short-term measures. Because of that, CEB, we will go ahead with some furnace oil power plant, reciprocating engines, as a short-term stopgap measures. Those should be commissioned by 2018. Okay, now these tenders will float. And we are going ahead with 3 into 35 megawatt gas turbines, because gas turbines, we need the system to peaking plants, frequency controlling. There are so many technical aspects. We need those kind of power plant. And this 300 megawatt combined cycle power plant, actually from CEB side, we float the tender and we evaluated the tender, and we think that we expect the open cycle operation by 2019 and combined cycle operation by 2020, but I think up to now that project was not awarded. Because of that, there will be definitely a delay on that particular power plant, because it's a huge big power plant, 300 megawatt power plant. Okay, then we have to find the stopgap measures for that particular power plant as well. Okay, but here main issue is CB did our part, and we maintain our timelines. We published the tender, we evaluated the tender, but still no LNG. That's the main issue, because we expected government will float another tender to get the LNG by 2020, because definitely this power plant will run either by HFO or diesel for next to maybe, I don't know, until LNG infrastructure is available, because that would be a huge environmental disaster within the Colombo. Because if we run, because now itself, why from planners point of view, we specifically power plants in Colombo, because Colombo at present itself we are exceeding the emission levels. That means we need LNG in Colombo. Power plants by 2021 and 2024, I think those are government wants to go ahead as a G2G projects. And from CEB point of view, we are proposing in our, because we are proposing energy mix, not only the LNG, we are proposing coal also. We are going ahead with the high efficient coal power plant. We have done the feasibility study. There were 3 locations, Hambantota, Trincomalee and Marvella, but government requested us to go ahead with the Trincomalee location, foul point area. But here we have proposed a high efficient coal power plant, not the standard subcritical coal power plant. You can see the pure capital cost. This is the conventional coal power plant. This is the high efficient coal power plant. This is the supercritical. You can see what kind of additional investment we have to incur, mainly to look into this high efficient coal power plant. And efficiency is increasing, and you can see the emission levels. These are the Sri Lankan standards specified. This is the World Bank proposed standards, and these are the power plants we are proposing. Because from as a CEB, as a responsible organization, we have to look into the environmental aspects. We have to comply the international standards. And here we are going ahead with the indoor cold storage, closed conveyors, and we complied with the Sri Lankan and international standards, because actually this is from the CEB side. We have presented those things to the government. Ultimate decision is with government. I think I will stop here, but I will again do the contingency plan and other thing, and the transmission network will be carried out by the Dr. Wijekoon.
I think maybe 5 to 6 months exercise has been summarized within maybe nearly 40 to 35 minutes. I mean, a lot of things, including the data collection, especially we have to do the data collection part very carefully. Otherwise, if you select the data in a, not in a proper way, whatever the output you are getting from this plant will not be a, realistic one. So therefore, in the transmission plan, actually until 2015, so we also basically did the plan using conventional approach. So that means we prepare conventional generation plan, and then we prepare the transmission plan based on the conventional generation plan. But with the penetration of variable renewable energy, so we have to basically deviate from conventional plan, and then we have to use a integrated approach. So therefore, in this planning exercise, basically we do prepare 3 plans. The one is we started from some renewable energy scenario, And then we carry out variable renewable energy scenario, and then we schedule the conventional plants for the balance, and then we carry out the operational study, and then we carry out the transmission network study, basically stability and all these kind of load flow exercises. So then we prepare the renewable energy integration plan, and then we started the whatever Buddhika presented here now. So after completing this generation plan, then we start the transmission planning. So you can see that basically we also think of the system size. Compared to the system sizes in other countries, we can see more than 100 gigawatts, 200 gigawatt system, 250 gigawatt systems are there in the world. But if we look into our system, it's a very small system, 2.5 gigawatt system. So therefore, even 100 megawatt is a sizable to our network. So therefore, we have to carry out, and the other part is the countries having the island nature. So therefore, all these aspects we have to basically carefully look into that. And the most important part is we cannot develop the power plants all around the country. So there are a specific location. If you look into that, so basically we have some potential here. Almost this potential has been developed. That is the largest power plant, Putham coal power plant, and then we have another site, Rinkomali, and we have some site in here and western side. So what are the most feasible location for the generation is basically all these 4 sites. So other than that, you can't develop large scale power plants in this country. So we can develop the small scale, some sizable renewable energy plant, inside the country, like solar. Even the wind you can't have inside the country because wind potential is very small inside the country. So I will start from just giving only the brief. I am not going to present anything on the transmission planning. So I will just highlight. So based on the Buddhika's generation plans, so we have prepared transmission network plan. So our approach is basically we started from 20-year ahead plan. So if we have 2018 now, so we started from 2037 transmission network. We look into that one, how the load basically having the natural demand growth. So we prepare the load forecast, and then we allocate loads around the country. Backbone network of 2017, and then we roll back the plan. So this is our present transmission network. You can see we have the backbone network, that's the 220 kV line. So this is the largest power plant. We have 3 into 300 megawatt, so that is 900 megawatt. So going from Puttalam and Anuradhapura and then Koppmale to Wijekoon, where Biyagama side. And from here it is passing Ilau and then come to the Wijekoon. So it is we have about 69 grid substations, and out of 69 we have 8 grid substations which are connecting the power flow from 220 kV to 132 kV network, and all the other grids, most of the grid substations, that is this 55 are basically cater for the loads. And then we have about 600 kilometers of 220 kV lines and about 2,300 132 kV lines. So you can see our network is very small, and also to cater for the voltage and reactive power. So we have about 300 megawatt capacity bank installed in the network. And so just to highlight, so the present network, so we have some weak points in the network. So we have identified all those weak points, and also so we have given proposals, and some proposals already completed, some are being completed, and also some will be committed in future. So these are just to highlight. You can see it is somewhere here, and around Colombo also we have some. So those are basically due to the capacity limitation in the transmission transformers and maybe in the transmission lines, and like that way. And also you can see, so there is no development for in the either the generation or backbone network has not been developed to southern side. So therefore, southern grid having weak in this present system, but the plans are underway and implemented the backbone network. So that means somewhere from here it will be going to Hambantota side, this 220 kV line, and then with that one the southern will be this constraint will be rectified. And this is just to give you, so this is the present network, and this is after 5 years, 4 years. So you can see the development of major lines. So we are having the cable network from Kerala PTA to the Port Tail, that is the Colombo 220 kV underground cable line. And then we have another development in Habarana. So that is 220 kV to 130 kV development, and then from there we have Habarana Vayangoda line, and also we are having another line going from New Pole PTA, and then it is going to the Padukka side. So you can see from 2017 to 21, so most of the weak points in the transmission network has been rectified, and most of these projects are some are near in completion, some are basically will be completed in 2019 and 2020. And this is going from 2025 to 37. Yeah, 2025 to 37. So I have not given the 132 kV network. So you can see this is our 220 kV development. So especially the Colombo will have a 220 kV ring. So the Colombo city will have a 220 kV ring outside, and there are 220 130 kV grid substations to cater for the large loads in the Colombo. The port city, it is estimated the load will be about 350 megawatts, and the Colombo load will be about another 500 to 600 megawatts. So almost 1 gigawatt load will be around and in the Colombo city during this 15 to 20 year period. And we can see almost all these 220 kV line. So those are catering for the renewable energy development in this northern side. So this line is basically for the wind power developing in this Mana Island, and then they are bringing through this line to the center of the load centers. And also we are going to have the Punarine development, what Buddhika told. So still we have not identified the potential. So but we, I mean, SCA is telling about it can go up to 1,500 or 2,000 megawatt. But we need to screen because there are a lot of issues, like Buddhika told, we have sand dunes and there are a lot of environmental issues. So therefore we need to filter out, and then we have to basically identify what is the actual potential which we can develop. I mean develop the size the transmission network. So based on that one, so we assume it to be about 600 to 800 megawatt, and then that can be catered by 220 kV lines. And here also you can see, so we assume the Hambantota will be the power plant will be developed in Hambantota more than 1,000 megawatt. So when it reaches to more than 1,000 megawatt, we need to cater through a 400 kV line. So that will go from Hambantota via Ambalangoda up to Padukka, and then we will have another development. There's a western development, so which are basically now one tender has been floated. So that is the Kerala PTA. So we assume they are also, it will be developed about 1,500 megawatt. So then we have a line going from the one is actually this is coming from, starting from Kerala PTA to Colombo Port City or Port Tail substation. We have two cable lines, 220 kV, and then we have a 400 kV line from Kerala PTA to Kirindivalla, and then Kirindivalla to Padukka. So this line is under construction. So it is 400 kV construction. Initially it will be operated in 220 kV. And also we can see there is another 220 kV development from Habarana to Kiridivela, and also with the development of Trikopali power plant. So we also assume it is also there will be developed more than 1000 megawatt. So therefore definitely we have to go for 400 kV transmission line. So then it will be we will develop 400 kV substation there, and then Sampur to Habarana, it is about 95 to 100 kilometer line. So that will be initially operated in 220 kV, and when the power level is developed to more than 1000 megawatt, then we will operate it in the 400 kV level. So these are just to highlight the 10-year planning horizon, what is we are going to publish. So each year, so what are the 220 kV, 400 kV, 132 kV and substation wise development each and every year. And also we can see the reactive power compensation is very important to maintain the voltage levels, especially in and around Colombo. And also we will have another SVC device to be installed in Wijekoon. So that is also under consideration, and then the funds has been committed, so that is under implementation. And then this is just to show you the committed and uncommitted project, funding for all this development. So nearly about $1 billion US, so 1,000 million US dollar projects are being implemented. So it's a massive amount, nearly $1 billion dollar transmission projects are being implemented. Several from JLanka and ADB, and we have some component from AFD, and the difference basically the local funding basically coming from the government. And also we are discussing, and then this is coming on and off depending on the Indian commitment. So initially, so we have done all the feasibility for the connection through Indian grid to Sri Lankan grid. Initially it was actually not Habarana, so it will be in the new one Radhapura. But now recently we had again started the discussion, and due to the large distance of 120 kilometer submarine cable, the earlier proposal was not materialized because it will be very huge cost, and then transmission 500 megawatt about using nearly about 350-370 kilometer line, including 120 kilometer submarine cable. So investment is very high, so we can't justify the investment. We are thinking of reducing this to the cable line to about 50 to 70 kilometers, and then we are re-evaluating all these capital costs, and also we need to think of the Indian market. So compared to the last 5 years, if you look into the Indian grid development, there is a massive development in the Indian grid. So now almost all the part in the Indian grid has been integrated, and there are synchronous connections. So therefore, and also they say about 20,000 megawatt in excess in the high voltage level. So therefore, that means we will have the low cost power in the Indian grid. Sometimes we can enter into the Indian market. So then we are thinking about the possibility of getting this connection so that we can get cheap power in the Indian grid. So that is also been considered. And this is actually just to highlight whatever our contribution, transmission investment. So mainly we are catering from the soft loans through ADB and JICA, and also the World Bank funds. So each year how much we will invest in for the transmission in order to cater for the or integrate the renewable energy. Okay, so that is about the transmission network and the transmission development. And just to highlight you, so this again, this is not the finalized plan. So this is subject to the approval of again the generation plan. Generation plan change, again we need to repeat this exercise. It is a massive exercise, so carrying out studies. So therefore, anyway, so we have completed just for going in line with the generation plan. Okay, so I will again hand over to the Buddhika for the other part of the presentation. Thank you very much.
Actually, when we are presenting the generation plan, we have to prepare a complete plan, because we have to look into the contingency aspects. That means mainly what would be the impact if we our variations in hydrology, variation in demand, because last year I told that we expect around 4,000 gigawatt of hydro, but we received only 3,000 gigawatt. As a planners, we have to think what would be the impact to our plan. Because of that, we will look into different contingency event, variation in hydrology, variation in demand, delays in implementation of power. Reasonable delays, but there are some delays beyond our control. Okay, and also we have to consider the long period outage of major power plant. Okay, it's a possible thing. Maybe now everyone knows now Sojitsu Kalnitissa power plant is out from last year July up to now. That means 163 megawatt is out. But we have to cater the power. Okay, because up to now we don't know when that power plant will be come into the operation. The same way, maybe one of our coal power plant can out. Those things we have to look into that, because in single occurrence of an event, our plan is robustness. That means we don't want to have additional power plants. But simultaneous event, that means whatever the major power plant is out and lower level of hydrology. Definitely we have to get the stopgap that measure. That means we have to get the emergency or some kind of thing as a short-term measure that we have to identify it in the plan itself. Then it's easy to get the approval from our legal framework, that means from the Public Utility Commission, because we have identified around 150 megawatt. If the simultaneous occurrence of event happen, we need some 150 megawatt as a backup that we will call as a supplementary power for a short term period, because now itself we are running around 60 megawatt short term power plants. Likewise, we have already identified in our contingency analysis, and our main concern is suddenly if government cancel the matured power plant, that we have to look, because you can see how much difficult to carry out a feasibility study. We have to obtain so many statutory clearances, entering into so much. This is not, I am not talking about the Sampur cancellation. This would happen to LNG power plants. This would happen to the wind power plants, whatever the power plants, because it's having longer gestation period to initialize this power plant. And our main concern is this to convert that power plants as a matured power plant. We need more than the construction time, because let's say after awarding the contract, that means all the things we have cleared, all these things only 4 years and for maybe 5 years. But to accomplish that target, we need more than 5 years. Okay, but up to now we didn't see any feedback or any report on that advice to the government on the adverse impact of the Sampur cancellation, except Professor Kumar David's report in the Prime Minister appointed committee, because he has calculated the value and mentioned. But there was a report in financial delay for the 300 megawatt LNG power plant. That's definitely we also know that will be delayed, because up to now it's not awarded, because then we need at least to construct the combined cycle power plant to run on open cycle. We need at least more than 1.5 years. 1.5 years, because we expect by 2019 that will run on open cycle mode. Definitely that will go. That will have an impact, and definitely these stopgap measures will cause delays and also expensive. That's a must we have to think. And this is the recent publication by the Public Utility Commission. They mentioned 50.6 billion is the cost of delay, but they also mentioned there was a delay of solar power plants because they calculated all the solar at 1186 rupees cents. Okay, we also, as a CB point of view, we also like if they allow 11.86 for all rooftop solar. But we know no one will implement rooftop solar at 11.86 because we have to give 22 rupees. That's the commitment. Maybe for 7 years, then after that 1550, that's the commitment. Then because we clearly mentioned, okay, there is a 2 billion loss for this delay. Umaoya delay, definitely there will be a delay and there will be a loss, but that should be borne by all the stakeholders. It's beyond CB control. Okay, because okay, maybe government, all the other stakeholders should act, and main thing is they have to take. Now Umaoya development has been taken by the government as a project, then everyone should go and implement that particular project. And what are the immediate action? Umaoya should be commissioning of wind farm by 100 megawatt, because this is energy. This 100 megawatt wind farm means 320 megawatt, 350 megawatt energy per year, because otherwise we have to cater from some supplementary power, because those things we have to consider. All the solar power plants also. This we are going ahead with some reciprocating engines. This combined cycle power plant 300 megawatt. We also don't know what would be the commissioning year, or let's say we don't know still what would be the awarding year also. And development of the LNG infrastructure, that's the must, because we are talking from I think more than 2 years now itself. Up to now nothing happened on ground. That's the thing, because to become a reality, first government should award the contract. I think government will take this as a serious thing, otherwise that will be a disaster for the environment in the Colombo, because this power plant will commission using diesel. That's the main thing. And G2G commitments, there are 3 G2G projects. I think those will come through. And we are proposing coal power plants, maybe 2023 or 2025, we are proposing to the government. And other main thing is, in parallel, whatever the project, transmission network should look into, because government is mainly looking at the development of the power plants. They are talking about the Punarine, they are talking about the Monaragala, but in the meantime, government should look into find the investments for the transmission network as well. Because we should not allow private sector to develop the transmission network, because that is not a dedicated transmission line to cater their system, because it's a common to everyone, because otherwise that cost also transfer to the consumer. And this is my last slide. This is the conclusion, because now actually we are currently based on mix of imported fossil fuels and local indigenous resources. Our plan, we are trying to diversify the energy mix, diversify the fuel mix, and we are trying to utilization of the indigenous renewables, mainly wind, solar, mini hydro and biomass. And also we are trying to initiate the use of local natural gas, because whatever, if we find the local natural gas, there is no issue, because they can utilize our existing power plants. Then this is the main thing I want to highlight. Power sector development projects involve unique social and environmental characteristics such as public consultations, feasibility studies, bird migration studies, because all these major wind power locations are along the northern belt. I think we had a very good experience for the Mana development. 2 years we have to count the birds. Okay, because their migratory pattern we have to count. Until that we are not getting the environmental clearance. That kind of period we have to look into. And main thing is this responsibility, renewable energy project, whatever the project, thermal project, whether coal or LNG or whatever the project, this responsibility should be shared all relevant government institutes, not only the power utility. Public utility also has a role. Our ministry also has a role, Central Environmental Authority, all the stakeholders. Maybe most of these wind power plants development area belongs to the Coast Conservation Department. Because once we apply for the EIA, CEA will transfer that to the Coast Conservation Department. That will be a completely new work to them, because they have to learn from beginning. And our ultimate responsibility is to come down the cost, because otherwise our Sri Lankan products may not competitive in the world economy. That means we have to have a balanced, low cost, environmental friendly, all the terms should be there, but ultimately we have to have a cost effective tariff system, otherwise our industries may not come true like government wish. I think that's the end of our presentation. Maybe there are different views, but we have to come to one conclusive statement by the government and finalize these power plants, because without having a plan means that will open to the so many unsolicited proposals, ultimately that lead to the emergency power. That's the main thing we have to think. Okay, thank you very much.